Hello and welcome. If you expected today's video to be on Codeforces round, D3 round, then I can understand you because I also expected it to be about Codeforces round. But the reality is that Codeforces had some internet provider issues, and as a result of it, the round got delayed. It will happen tomorrow. So I decided to spend my time in a different way, but still, I don't know how to say, in a somewhat useful way. I'm not sure how useful it is, but yeah. So I decided to upsolve yet another contest that I missed, and I don't know. Why don't I upsolve yet another LeetCode contest, apart from them being not all that interesting? We can still learn something from them, so let me make it around so. And yeah, and I missed Biweekly contest 51. I also believe that I haven't seen the problems yet. We can, I don't know. I'm pretty sure that there are like previous 4 problems, so the last 4 problems we solved yesterday. Let me just quickly check that I haven't solved anything for it to be more or less fair. It takes a lot to load, I'm sure. Yeah, as you can see, like I wasn't solving anything since I don't know what time it is, but definitely not Biweekly contest, not last Biweekly contest. So yeah, this is the contest we solved yesterday, and we are going to upsolve Biweekly contest 51 today. Just like that, let's go to contest. Same as yesterday, open all problems first, read later. I lost a little bit of time there, but nothing critical. Nothing critical. So problem A, replace all digits with characters, and let me just quickly make it like this and like this. So we're given 0 index string as it has lowercase English letters in its even indices and digits in its odd indices. Okay. There is a function shift cx where c is a character and x is a digit that returns the x character after c. What? Okay. Yeah, I got it from examples. For every odd index I, you want to replace digit si with shift si minus 1 si. Okay. Or actually, it's another. Okay. What if we just get the length and then for each index in range, I don't know, let's say n, from starting at 0 to n with step 2, si plus 1 gets, will never exceed z, it's guaranteed. Okay. So what we should take is we take order of si at si plus 1, convert it to character and return string. The only issue is that string does not support item assignment, I believe, in Python. So we'll have to do something like that. Run code, we expect to get ABCDF and ABBDCFD, something like that. Yet we don't, of course, we need to cast the digit to integers. Last index out of range. Why would that happen? Oh, because the last one can be... Okay. The last one can be apparently letter. Well, if we do it like this, everything will be fine. ABCDF, ABB, DC, LE, HI, HE. Okay, let's also test, I don't know, some invalid test case. Lengths have to be at least one. Cool. Right, we got accepted, so you just needed to be careful with that last letter. But they were nice of them, they give it to you in the samples. Problem B, maximum element after decreasing and rearranging. So we're given an array of positive integers array. Perform some operations, possibly none, on R so that it satisfies this condition. The first value is 1. The absolute difference between any two JSON elements must be less than or equal to 1. So from value v, we can go to either v plus 1, v, stay at v, or get to v minus 1. There are two types of operations that we can perform any number of times. Decrease the value of any element to a smaller positive integer, and rearrange the elements array to be in any order. We want to return the maximum possible value of an element in the array after performing the operations to satisfy the conditions. Okay, suppose that we just I don't like this name. Our array will be named A. What if we sort it and then for E, n gets length of this array, for E in range, I don't really know, from 1 to n, AI gets, what should it get? A minimum of AI and AI minus 1 plus 1, and then we want to return, also array at 0 gets 1, and we want to return array minus 1. Just some greedy thing going on. 2, 3, 5 looks legit. I don't really know what this problem is about. Like there is no point in the resulting order not being the same to initial order. So we just do this and this should be fine. Yeah, I got accepted. I don't know what this problem was about. Like we just greedily, like we sorted because there was no point not to sort. We want elements to remain in the sorted order, and then we just use our greedy approach. Like if we can, this is the value, if the max value we can get judging on the previous element, and we are also limited by the value, by our current value. So that's it. Problem C, closest room. There is a hotel with n rooms. The rooms are represented by a two-dimensional array rooms, where rooms I is room ID and size. So each room has ID and size. IDs are guaranteed to be unique. Thank you very much for that, because otherwise they would be of no use, right? We are also given k queries in a two-dimensional array queries, where queries j is preferred in minimum size. The answer to j's query is the room number ID of a room such that the room has a size of at least minimum size, and absolute value of ID to preferred is minimized, where absolute value of x is the absolute value of x. Makes sense. If there is a tie in the absolute difference, the smallest ID, if no such room, the answer is -1. Turn the array answer of length k. This is actually interesting. Like it's very easily can be solved with SortedList, I believe. But I don't know if will this give me a compiler? Well, not compile, but runtime. SortedList. Okay, let me try to include it somehow from sorted containers. Because if it's possible, then it's very simple. If it's not possible, then oh, very good, very good. We can just include it. I don't know why they did not include it by default, but whatever. So my idea is, of course, to sort both rooms and queries. Although rooms should be sorted by size, and queries should be sorted actually also by size. Minimum size, by minimum size. Well, it doesn't matter that much, but yeah. Apparently, for some reason, operator is imported, but sorted containers are not, but it's fine. So my idea is what? We will have I and j equal to 0. We will have n and k equal to length of rooms and length of queries, with the idea that we will do something for, we will also need an array of answers, okay? So at the very end we can return array of answers straight away. And then we will, for each query, oh, I should not have done this. What I should have done is list, like I want to remember the ID of the query. So j will be its ID, then I have preferred, and then I have minimum size. For preferred minimum size in, I actually want to sort them based on minimum size. So I should also pass a key, which is now item getter 2. I hope they have a recent version of Python. We can just make sure that we're doing everything right. Generator expression must be parenthesized. Whatever you wish. Well, that's kind of expected. What do I want to get? Actually, this is fake j, okay? This is like fake j. J then preferred and minimum size gets queries. Oh, actually, I just want to loop over queries. What am I doing, right? You are absolutely right. Okay, so queries, we appended 0 here, we appended 2 here, and 1 here, and then we sorted by last value, which is 1, 2, 3. Everything is fine. So here we want to add all rooms of, wait, actually, Assuming that we want to process them in decreasing order of size, apparently. And I also would like to know what should we do if -1, okay. All right, so we will have to rewrite this a bit, but not much. No, we don't have some. Or it should be like that, actually. Let me just, yeah, we're spending a lot of time here to write this properly. And like run code multiple times, but it will be useful. Expression can not contain assignment. Oh, I don't have to return, I can do just this. Am I right? Missing one, okay. So it is still item getter 2. The tuple index is out of range. Is it because it's like the first element of the expected 3 got to? I suppose now this is because we want to write it like this. And after eternal waiting, we should. Oh, okay. This was stupid of me. GPMS, minimum size is not decreasing for some reason. Oh, probably because item getter doesn't work like that, right? Okay. Yeah, one just returns a tuple of 2. Twice the second element. Now it got sorted, okay. Rooms were sorted, should also be sorted in the reverse order by size, because our idea that takes eternity to implement is the following. While we still have rooms, and rooms, the current room, its size is greater or equal to minimum size, we should insert. Do you know what? We should insert ID, which is rooms I0, into our sorted list and increment I by 1. With the idea that by the time we did all of this, we now have all rooms with at least given size in our sorted list, and we can binary search for preferred ID. And then answer J, let's just get. So K gets what does it get? Bisect left, I believe, of preferred ID. This will be the smallest values it is at least P. We should subtract -1 from it. Oh, let's do the following. If not sorted list, AJ gets -1, just to protect ourselves from any stupid mistakes. Now, this will be the smallest values it is at least P, so therefore it will -1, it will be the largest value that is that is smaller than P. Alright. So if K is at least 0, let me also create minimum absolute difference. I'm not sure if you can write like this, but let's just leave it for a moment, and if not, we will fix it. If K is at least 0, then sorted list at K is some ID, and if mat is greater than then preferred ID minus this ID, and we can avoid absolute value like that, because P is smaller than because sorted list at K is smaller than preferred ID. Mat should get this difference, and IJ should get sorted list K, and then we check if K plus 1 is smaller than length of sorted list. There is such index. If mat is greater than sorted list at K plus 1 minus P, mat should just get this value, and IJ should get sorted list at K plus 1. Whew. Wow. That sounds really complicated for problem C, honestly. AJ is because AJ should get -1 times len queries. And here I believe we can simplify this. Yes, so 3 -1 3. 3 -1 3. But it's not enough. Oh, we used only one example test case. 2 1 3. 2 1 3. Well, that sounds reasonable. I have no idea if it's going to work, but we can test it. Right. Okay, it got accepted. Wait. Ah, that's why it's so hard. It was not Q3, it was Q4. Actually, apparently I missolved them, the order, because, yeah, we just solved the hardest problem. But whatever, yeah, sorted list is your friend whenever you code in Python. It is like, it is actually more powerful than, I don't know, than std multiset. It's approximately equal in strength to policy-based data structure tree, which you can only access if you compile with GCC. So yeah, sorted list from sorted containers is, I believe, at least as powerful. But anyways, in this problem, which I believe is actually a second problem, so we solved them in the order 1 3 4 2. Okay, so in this problem, seat reservation manager, we want to define to code a class, which I don't particularly like, but whatever. Let's keep reading. Want to design a system that manages the reservation state of n seats that are numbered from 1 to n. Don't number your seats from 1, number them from 0. Be a normal person. So we want to implement the, actually, why don't cinemas have seat number 0? Sounds cool to me. I mean, like, you are somewhat special if you get seat 0. Although it is most probably on the like edge of the row, so you would not like to sit here, but whatever. So we want to implement the seat manager class. Seat manager initializes object which will manage and seats. Okay. Initially available, reserve smallest numbered unreserved seat, reserves it and returns its number, unreserves the seats. Honestly, sounds like another sorted list. Because what you... Yeah, number of seats is not huge, so... list, range, and what is reserve? Reserve is... We want to get... well, actually, there is it's guaranteed that there is at least one available seat. This is what I was going to ask. Because we want to get I, we want pop 0th element. I want to return I plus 1 because it's ID. And here we want just ordered list, add I plus 1, I minus 1 back. Use example test cases. We expect to get null 1 2, null 1 2, null 2 3 4 5 null. Okay. I don't really know what to check here. Why don't we just submit it? And it got accepted. Okay, whatever. I don't really know what they expected us to do. Maybe, like usual, we also finished like in 26 minutes, but this time we were pretty terrible, as you can see. Yeah, we are not even in the first 2 pages. We are somewhat like, oh, we're exactly 50s. Well, at least we didn't have any bugs. Yeah, I just missed the order, so I spent like a lot of time implementing this, and actually this took me like, I don't know, 3 minutes. So yeah, again, sorted list is very powerful. Probably they expected us to implement, well, I believe that you can achieve the same result with coordinate compression and then fanwick tree. Or you may even have implicit fanwick tree when you don't create the array initially, but rather you substitute it with an ordered map or dictionary in Python, and then you create entries as you go. So actually you substitute with a default dict of int, so that it automatically creates zeros as it goes. Yeah, we were 1 second faster than 50%. Okay. Rankins, blah blah blah. And this implicit fanwick tree also has the same complexity, I believe, although it may create more keys than n. Like, for example, if there are 10 to the 5th elements, like from 1 to 10 to the 5th, then explicit fanwick tree only has 10 to the 5th entries, but implicit fanwick tree, if the range of inputs is bigger, it may create up to n log n entries. So you have to remember that memory usage can be also like has an extra log factor in it. So the coordinate compression should in theory save you from that, but to have coordinate compression you need another dictionary, which will not have an extra log factor of entries, but still it's a dictionary access. Like, it's still slow, I believe, in both Python and C++. Actually, last time I walked through binarysearch.com weekly contest, I decided to read editorials. And people were happy about it because they could see different approaches. Makes sense, right? Maybe I did not solve the problems the most efficient way. So what I will try to do now is to go through editorials for these problems, although on LeetCode there is no adequate moderation of these editorials. So I believe we'll see a lot of garbage here, but I'm pretty sure that some people reliably write good editorials on LeetCode as well. So let's see if we can find anything that's more compact than what I coded, so that you get a sort of broader perspective on things. Simple replace, straightforward codes. Okay, I actually know these two people. They are usually good, although not always. Like, let's see. Well, yeah, in C++ you can modify the elements of the string. Replace if file. No, it's the same condition. It is just one-liner for some reason. Okay. Like it's basically the same thing, although we could, like here you can just, I believe, instead of checking this, oh no, you need to check this either way because you want to preserve good characters, which are actual letters. Maybe. There are not many ideas to that problem, so. Let's keep going. Seed reservation in Python. Heap. Actually, yes. Sorted list, heap. Okay. I did not thought about it. Sorted list actually can do everything that heap can do and more. The only advantage of using a heap is, of course, that your container is a continuous chunk of memory, right? Because heap queue modulo in Python operates over an array, so it should be faster, right? Than some, I don't know, red-black self-balancing tree with some additional information stored at each node, because like bisect has to work somehow, and return index. So every subtree at least should know its size, which is of course many random memory accesses, because like you have pointer and you have to go somewhere to get to the left or right child. Now usually that's not a problem because everything lies in I don't know, L2 cache. L2? Yeah, probably not in L1 because it's very small. Maybe not even in L2. Whatever. Pretty much everything like of 10 to the 5th elements lies in the cache of some layer of it, so it's not a major problem for you, but heap is generally faster, so that's cool. Should actually upvote this editorial. Maximum elements after decreasing and rearranging. I don't really know what to say here. Yeah, we just sort and then, oh, we could do it like so. It doesn't really matter, like it's the same thing. Yeah, it's more or less like, do you want to change the elements or do you want to create a temporary variable that will keep track of these changes? Doesn't really matter. So I don't see anything interesting here. LeetCode contest became really easy recently. Like if you can solve medium question with 3 lines of code. Python sorted list solution. I like to see our people everywhere. Yeah, we enumerate queries, we sort them based on something, we get we reverse them, we sort rooms. Although, like, the difference is that the while loop is written in a somewhat different way. Also, all variables are meshed in one line. Cool. Very readable. You immediately recognize that available is sorted list and not, for example, 0 because you miscalculated the number of commas. So yeah, good code. And then if then available is not a 0. The entire Python language is about not checking the emptiness of the container like this. But whatever. Apparently, and also bisect. I don't really remember how bisect works. I do remember that bisect left has to be lower bound, lower bound, and bisect right has to be upper bound. And I don't remember about bisect, but I believe it's the same as bisect left. But I prefer to just use bisect left or bisect right all the time, because there is a model bisect, and bisect from bisect, I believe, actually behaves as bisect right. Although maybe it's also bisect right, because apparently we checked I-1 and I. And then we have a fancy way of selecting whoever gives the minimum absolute value. Okay, this is good. This could have probably saved us several minutes, but not really. Like, I was just very slow figuring out how to sort everything. And also, I think talking too much. Sounds like Russian surname, or maybe, I don't know. Yeah, actually. Dmitry Babichev, PhD. Okay. No, GitHub provided. Questionable rate actually had decreases on a relatively low rating. But clearly a smart person. Okay, let's upvote because sorted list, you got upvote. I don't really know if we want a second sort. Oh, yeah, I remember about this, but I just saw that it's bad. Maybe I know nothing. Yeah, some people complain about bisect and sort. Actually, for you to understand, sorted list, I believe, is not n log n, but something like n square root of n, or is it? No, square root, it was something different. Like, you can do something strange in Python that actually works as square root decomposition and not as binary search, but I don't remember what it is. So maybe everything is fine here. Yeah, also can do fanfic tree. Vol. Just. Then. Okay. Somebody likes to write their own binary search. What can I say? Yeah, no, I believe apart from heap, which should have been done with heap, everything we coded today is reasonable, so not much to comment here. But yeah, heap was useful if you don't want to use SortedList. I started to think like to reflect on myself. Yes, maybe I am overkilling some problems, but I can afford it. Okay, so like if it works, it works. There's not much of a difference if you use SortedList or a heap. Although it's probably better if I recognized heap in the problems that can be solved with the heap. So yeah, just like that, it will be all for today, and I hope to see you tomorrow in Codeforces round. And I say hope because it may delay the game. I really hope it doesn't, so we'll see you tomorrow. Bye bye.